Hey guys, welcome to third session of number systems in the playlist of quantitative aptitude preparation for mbaentrance exams. So, as I have been saying since past sessions, these are the several exams and scenarios where you will find this topic to be the core foundation and helpful in combination to several other type of questions. Before we delve into today's practice set, there are few topics which I need you guys to be very clear about, so I will just go over them. If you feel confident that you know them, you can skip to the later part, but it's better if you just see. You might find something that you may not have known earlier. So first we are going to discuss factors. Let's keep it simple. If I say what are the factors of 6, for that I will basically try to put it as multiplication of two numbers like these, as you can see on the screen. From these I will get the number there. Yeah, by dividing 6 with these numbers I will definitely get a completely divisible, zero remainder, and no fraction or integral values as quotient. So basically these are its factors. Similar to that, if I do for 56, I will get these values. Now notice here, when I try to represent 56 as a product of two numbers, I didn't go after 8 times 7 because here the difference between these two numbers became 1 or equal to 0, difference between them. So that's a kind of a signal that after this the pattern which I have already written is going to be repeating, but in a reverse order, like 7 times 8, 14 times 4, 28 times 2 and 56 times 1. That's the general gist of it, to get the factors in a faster way. Now the main reason we did that was because I want you guys to get acquainted with the prime numbers. Similar to 6 and 56, if we try to write 2, 3 and 11, we will only end up with these two pairs, that is the product of number with 1 itself. So what we can conclude, that these numbers are only having two factors, and exactly having two factors is what we call being a prime number. So these kind of numbers are primes, and just for your information, between 1 to 100 there are exactly 25 primes, and between 1 to 200 there are 46 primes if you can count total. The reason I'm giving you this information is because there have been several instances in CAT, SNAP and ZAT exams where sequence and series type questions are being made from primes, like 25 sequence of 25 numbers exists where there is no definite difference between the two, and there are some properties given. Basically they will try to play word games around the properties of prime without telling you that it is a series of prime numbers. That's why you need to know at least this basic, so you can at a glimpse catch that yes, it is a sequence of prime numbers or series of prime number. Now a few basic things that I'm sure many of you might already know, being that 2 is the smallest prime number and the only even prime number. I think that makes sense because other even numbers are obviously, yeah, 0 is a even number, but it does not have exactly two factors, it is only having one factor, and other even numbers they are always multiple of 2, so no chance for them. So if ever someone asks what is the smallest prime, that will be 2. Of course the normal smallest prime and the only even prime, if I have to be specific, similar to that, if the smallest two digit prime, that will be 11, greatest two digit prime, that will be 97, and the smallest three digit prime will be 101. As for the greatest three digit prime, I will leave it up to you guys. Do let me know in the comment section what you found from Google Baba. Now moving on, as we have gone over primes, obviously the next will be composite numbers. At this point many of you would be thinking, yeah, opposite of prime is composite, right? No, absolutely not. Basic condition, they need to have more than two factors. As primes had exactly two factors, this is the condition where number of factors is greater than 2. It is never that opposite of prime numbers, it is factors should be greater than. And as while on the topic, as I was saying, 0 and 1, they have only one factor, that means less than two factors, so they are neither prime nor composite, and 1 is a unique entity, that's why it is neither prime nor composite, 1, while being part of natural numbers. So yeah, and another important property, that whenever you have a prime number, it can be represented in the form of multiplication of 6 plus or minus 1, but make sure to remember that it does not go the other way around. Like let's say I have a number 23, obviously I can represent it like 6 times 4 minus 1, but if I try to find value by this formula, it doesn't work like that. Let's say I take 6 times 4 plus 1, then what will I get? I will end up with 25, which is definitely not a prime as it is a multiple of 5. So it only works one way. Like if you know that, or you want to check it is a prime or not, then you can try this if it is working or not. But yeah, every prime number it will be representing like that, apart from 3, or you can say greater than 3. Oh, let me just get this call.
Hello, sir. Alvin here. Sir, you said something about knowing that it was prime, sir, but how will we know if a number is prime or not to check it? Or is there any way we can know whether a number is prime or not, sir? Please explain.
Okay, I think many of you might be having that question. So, let me tell you how to check prime, which was going to explain anyways. So, let's take a number 173. The basic thing I will do, first I will check whether it is divisible by or it is following this pattern 6k plus or minus 1 or not. If it is following, yes, then I'm sure at least one step that it has high possibility of being a prime. I'm not saying that it is a prime. I'm saying it has a high possibility of being a prime. So just to make sure, what I will do now, once it is satisfied the formula, I will find the square root of it and get some value. And I will round it off to the smallest integral value. Like in this case, I got 13 point something. I'm not interested in what comes after decimal. I will just stick to 13. Now what I will do, I will check the divisibility of this number by all the prime numbers lower than or equal to 13. Okay. So if it is not divisible by either of them, then it will be a prime. And I sure hope that you guys are at least calculating this much, and do let me know in the comment section whether it is a prime or not. Now some of the smart ones would just go back to the video and check that list of 1 to 200 whether it is there or not. Yeah, if you remember that, that is also the case, you don't need to check it, but for calculation practice it's a good one. Moving on, let's start today's practice sets. So here is your first question. If m and n are two numbers or specifically integers which are divisible by 5, then which of these statements is not necessarily true? Now here you need to pay attention, as they have asked not necessarily true. That means even if there is a one false condition existing for these statements, then that will be our answer. It is indirectly stating that. That means I have to prove them false, and whichever I can prove false, that will be my answer. Now basically, what are the integral values that we know? And it should be divisible by 5. So let's take any random number, but m and n can be any numbers, but the one thing I'm sure of is they will be integers and they will be divisible by 5. That means multiple of 5. So I will obviously be taking numeric value, but also incorporate a variable term which is a multiple of 5, like 5a. Similar to that, the second number would be 5b. Now I will try to do these operations on both these values. As you can see here, if I am getting the numeric value, I am getting minus 5, which is, yeah, obviously divisible by 5. Even though the quotient would be negative, it is completely divisible by 5. But I am not always sure whether the numbers will be 15 and 20, right? They can be any multiple of 5. That's why I introduced this variable. If you look at the variable simplified version, you will notice that 5 is coming out as the common product of the difference which I am getting, a minus b. So no matter what numbers, a and b can be anything, but this constant 5 will always be there at the out common multiplication. So this proves that whatever the value will be, it will always be a product of 5. That means it will be divisible by 5. That means the first scenario you can just eliminate. Second one, let's do the same approach. This time I will be taking 10 and 30 and I will again repeat the operation. This time we are squaring, and similar to first case, we are getting 25 as the common product. And as you can see in the numeric value as well, they are both divisible by 25. So this scenario is also true, always true. Coming to the third one. Now do remember I said we have to prove them false, right? So I will try to pick some number whose addition will definitely give me something which is not divisible by 10. Obviously variable term is there, but just to make sure, I will definitely try to take numbers which are not divisible by 10, whose addition will not be divisible by 10. So I took one multiple of 5 and other one not not having 5 at the sums place, because this will definitely return in something with 5 at the units place, and that will not be divisible by 10, as common logic. And even after this, it is possible you may not think like that, so you have this variable as backup, that yeah, 5 is coming as a common product, so we are sure that it will be divisible by 5. But same cannot be said about 10. Sometimes it may be true, sometimes it may be false. So it is not always true or not necessarily true, right? So that's why this is our answer, because if it was divisible by 5, we can be sure, but by 10, it is not always true, right? So that's our answer. Moving on to our next question. This time also around primes and number tree. If I have having a prime number which is greater than 3 and I do this operation of a square minus 1, then the final value will be divisible by which of these? Now here, what are our prime numbers greater than 3, we all know 5, 7, 11, 13, 17, 19, and the list goes on, right? So let's try to approach this in a very sensible or simple way. I will just simply do the operation and be written with the value of 24 if I take 5. So yeah, this operation shows that yeah, it is divisible by 24. Now if it is divisible by 24, I don't even need to look at the option 6 and 2, because 6 and 2 are factors of 24, right? It's just like saying if I can make a mansion, I can definitely make a house, right? So if number is divisible by 24, it is obviously divisible by its factor as well. So obviously the answer will become all of the above. But that's not the question they have asked here. In if I have to simplify this, it's basically asking whether this all the possible prime numbers, any prime number which you do this operation a square minus 1, will the final value always be divisible by 24? That's what this is asking about, because then the answer would be all of the above. If not, then some other value we have to consider, like 2 and 6. So let's try a few different numbers as well. I will just need to check whether it is coming around 24 or not, because 24, 6 and 2 are factors, obviously. Now, again, I will return with 48, which is again factor of multiple of 24. So, divisible by all. Let's keep 11. I will just try to make it a bit random and take 13. And again, it is divisible by everyone. So, yeah, if this operation for all primes greater than 3, I am getting all of the above. That means 24 and all its factors are completely dividing this value. And here comes an important property, that it is actually a property, That's why I made this question. If you have any prime number greater than 3 and you do this operation, that value will be divisible by 24 and all these factors. It is a property of prime numbers. Moving to the next question. Now, I think around 10 minutes have passed or 15 minutes. So just to freshen up your mind, let's play a game around numbers. I really love this game. So first choose any 3-digit number. And don't try to take 099 as 3-digit number. That's a 2-digit number. Just select number from 101 all the way to 999, any number between that. For showing you what to do next, I am taking 578. You can take any 3-digit number from 101 to 999 and just write it again after itself and make it a 6-digit number like this. Now divide it by 13, whatever the value you get, divide it by 11, and again whatever value you get, divide it by 7. Surprised? That's the magic. I'm sure many of you might be surprised. And if you are enjoying this video, a like to the video would be fabulous and a sub to our channel would be magical. Okay, now about how this happened. Basically, what you need to know is these consecutive prime triplets, product of consecutive prime triplets. That was what I used. This 1001. So whenever you multiply 1001 with any 3-digit number, you get its repetition in 6-digit form. That's what I made you do, but in vocabulary form. I'm quite sure until you saw this number, you didn't know what you were doing. You just did as instructed. That's how the questions play with your mind in CAT and SNAP or XAT exam. They make you do things verbally, but you are already doing some numerical operations on them without even knowing. So that's why when you try to solve them, you are just unbuckling them or going backward in calculation one by one. That's what we were doing. I made you later divide that by 13, divided by 11, and divided by 7. If you notice, 7, 11, 13. So basically, I just first made you multiply it by 1001. Then I made you divide it by 1001 to get that same value again. So that's what it was. And you need to at least remember these 3 values or product of these consecutive primes. It comes very handy in sequence and series type question, where there will be some variables introducing. You will have to take x, y, z, a, and then you will try to find product. In that case, if you know that this is the value, it will be helpful. And there are actually CAT PYQs which have used these values. I will make sure to include it in our session. So do look forward to it. Now, I think your mood is now freshened up. So we can move on to next questions. Let's do this set. Now, this is a word play, but let's see how we can do it in simple manner. X is a set of real number values of r such that r square less than r. Which of the following covers every single value of x? I'm sure many of you might be struggling, but let's focus on the r square minus less than r part first. What I need to know that, real number values of r, that means r has to be a real number, and it should follow this operation that when I square it, it should be less than original value. Now, if you guys know about number tree, then if I think of negative numbers, obviously when I try to square them, the value will be greater than them, not less than them. I need less than. So negatives are out of the picture. Similar to that, if I take any positive number greater than 1, like 2 and 3, they also will follow the same thing. So I can also eliminate them. What I'm left with is 0 and 1, but they are also equal to their squares, not exactly less than, right? So what to look at now? That's what a dilemma is. But again, you need to focus on the question. They have said for real numbers, and between any two integers there can be infinite real numbers. So let's try between 0 and 1, because 0 and 1 there are 0.5, 0.3, there are infinite possibilities of number between these two. So let's try with that. Now we will notice that yeah, numbers between 0 and 1, when I square them, the value is getting smaller. That means it is fulfilling our scenario, right? So at least I know now that all the values between 0 and 1, excluding 0 and 1, between 0 1 but excluding 0 1 themselves, will yeah follow this pattern. So now I can definitely take 0 to 2. Before you come on to me saying that just because it was the closest value we chose it, nah, that's not the case. I will ask you to pay attention to the second part of the question. Which of the following covers every single value of x, where x is the set, or we can say the all the numbers bunched together, that's what we are calling x, that set, and it should cover, not exactly match. Okay, so 0 to 2 and this round bracket it indicates all the values between these two but excluding these two. So yeah, if I am talking about 0 to 2, it is including all the 0.1, 0.2, 0.3 and every value, right? And of course 0 should not be included. So yeah, it is not including 0. This round bracket it means that excluding the limits, excluding the maximum and minimum value and everything in between. That's what it means. So yeah, this is fitting my scenario, although there are values greater than that, but it is covering my required range, right? That's why D is the option. And just an important note that between any two integers there are infinite number of real numbers, be it 0 to 1, 0 to 3 or 0 to 4. Real numbers include all the rational, irrational and every number. So there are infinite possibilities for that. Moving on to next question. Let's try to solve this. I am given a sequence, and yeah, it is a CAT PYQ. So good practice for you. I am being given a sequence, basically number with inverse of itself in the power, and I need to know what is the greatest value here, right? Now here, as soon as I saw this, I just remembered the basic jugaad we used in trigonometry, like root 2 is equal to 1.41 and root 3 equal to 1.73, right? We used it very much in trigonometry to solve question. Although they are rounded off values, but yeah, from here itself I know that root 2 will be greater than 1. That's a basic fact. So 1 I don't even need to check, and that's why they haven't even given me the option. What I need to check is between 2, 3, 4 and 6. And many of you might be getting nervous or panicking when you see n times form, like n raised to 1 by 1 inverse of its power. That means there will be infinite possibilities and all the logarithm, and you might have already made up that you will need to check. Don't ever panic by seeing the n. Always use options to simplify your way of solving the question. So here I only need to check for these 4 values. So at least root 2 I am sure it will be 1.41, but what about cube root of 3? I haven't used any value of like that ever since, in elementary school or in higher secondary, never. So how do I compare them? Well, I have already taught them in lecture 1, question 6 if I have to be precise. And what logic I am using here, you can just apply the power of 6 to both of them to bring them to, or we can say to level the playing field between them. And then I will know, yeah, the value of 2 that I am getting after solving and value of 3 will be greater. So obviously this 3 raised to 1 by root 3 will also be greater than 2 raised to 1 by 2. Now 2 option A you can eliminate. Similar to that, let's do this operation on 3 and 4. Again, I will be applying power of 12 to both of them in this case, because LCM of power 3 and 4 will be 12. So yeah, and if you are sharp, if you are having a sharp mind, you will notice here itself that yeah, first the pattern was going up, that means value was increasing, then suddenly it dropped. Then there is a high chance that number after it will also be dropping. Okay, so just to be sure, we will just compare 3 and 6 now, because there are only 4 options, no need to think about it. So I will apply power of 6 this time, because the LCM of 3 and 6 will be 6. And I will be left with sure answer that yes, 3 raised to 1 by 3 is definitely greater than all of these values. even in this whole sequence, if I am to be more precise, 3 raised to 1 by 3 will be the greatest value, because after this the value will keep dropping. Now moving to our next question, again a bit panicking one to many of you. 2 root 2 up to n times, how can I represent it in n raised to form? Now again we will take a very simple approach. Let's begin by 1. If I put n equal to 1, I will just have root 2, and if I simplify it, I can write it as 2 raised to 1 by 2. Okay. If n equal to 2, then I will have to add a 2 outside the root 2 and a whole square root. So if I simplify it, I will be left with 2 raised to 3 by 4. Now what I will try to do, I will try to put this value of n equal to 1 and n equal to 2 in all these options to check whether they are matching my answers or not, because this is a definite thing. The pattern that they have indicated, it is, we have just represented in index form, so it should follow if it is the correct option, right? So I will just put the value of 1 and 2 in first option. You will notice that at n equal to 1 itself, it gives something like 2 raised to 1 by 6, which is not my answer, so you can eliminate option A. Similar to that, option B, you will notice that yeah, it is following. For n equal to 1, it is following. Okay, I will keep it as it is, and I will try option C now. So option C also, you will not get any, the value we require, so option C will also be eliminated. Now you are left with either B or either D. So just to make sure, again you will put n equal to 2. Now you will put n equal to 2. If this none of this was not here na, life would be so easy. I would directly take B is the option. Okay, but just to make sure, I will put n equal to 2, and I will notice that yeah, it is following exact requirement, and it is returning 2 raised to 3 by 4. So that is my answer. So I hope you guys enjoyed the session. See you again in the next lecture. Thank you.